Hi there. In this interview, we are going to simulate a real DevOps conversation focused on IAM, permissions, and lockout scenarios. These are the kinds of problems that do not show up in tutorials, but absolutely show up in production. Think accidental root lockouts, broken CI pipelines because of a missing permission, or a deployment failing because of a subtle deny policy. Here is how this works. I will ask a question, pause the video, and answer it out loud, as if you were in a real interview. Then I will walk through what a strong candidate response could sound like. If you find this helpful, subscribe so you do not miss the next simulation. Warm-up behavioral questions. First question. Tell me about a time you broke access for yourself or your team in production. What happened and how did you handle it? Pause here. A strong candidate might say something like this. I once modified an IAM policy attached to a shared role used by our CI pipeline and some admin workflows. I was tightening permissions to follow least privilege, but I removed an action that the pipeline depended on. Within minutes, deployments started failing. The first thing I did was confirm the blast radius. I checked CloudTrail to see which API calls were being denied and verified that it was isolated to that role. I communicated immediately in our Slack channel that I suspected an IAM change was the cause and that I was rolling it back. I reverted the policy to the last known working version from version control. After restoring service, I scheduled a follow-up to properly refactor the role by separating CI permissions from admin permissions. The key lesson was to test IAM changes in a lower environment and to treat IAM as code with peer review and staged rollout, not as a quick console edit. Second question. Describe a situation where you had to balance security requirements with developer productivity. Pause here. A strong answer might sound like this. In a previous role, security wanted to remove all long-lived access keys and enforce short-lived credentials with MFA and role assumption. Developers were concerned because some legacy scripts and local tooling relied on static keys. Instead of pushing the change abruptly, I worked with security to introduce federated access using SSO and role-based access. We documented how to use short-lived credentials with tooling like AWS Configure SSO. We also updated our CI pipelines to use instance profiles and role assumption rather than embedded keys. There was friction at first, but by providing clear documentation, examples, and support sessions, we reduced the operational burden while improving security posture. I learned that security controls are more likely to succeed if you design them with developer experience in mind. Third question. Have you ever had to say no to a request for elevated permissions? How did you handle it? Pause here. A strong candidate might respond like this. Yes. A developer once requested full administrator access to troubleshoot an issue in production. Instead of granting it directly, I asked what specific actions they needed. It turned out they only needed read access to certain logs and the ability to restart a service. I created a temporary role with time-limited elevated permissions, scoped only to those resources. I also set an expiration and documented the access in our ticketing system. My approach is to assume positive intent, but enforce least privilege. It protects the company and also protects the individual from accidental damage. Core technical and scenario questions. Now let us move into technical depth. First question. Explain the difference between IAM users, groups, roles, and policies, but do not just define them. Explain how you decide which to use in a real production environment. Pause here. A strong candidate might say something like this. At a high level, policies define permissions. Users, groups, and roles are identities that those policies attach to. But in production, the design decision is about lifecycle and trust boundaries. For human access, I prefer federated identities through an identity provider rather than long-lived IAM users. Groups can still be useful conceptually, but ideally group membership is managed upstream in the identity provider. Roles are my primary building block. Roles are assumed, which means credentials are temporary. For applications running in AWS, I use roles attached to EC2 instances, ECS tasks, or Kubernetes service accounts through IAM roles for service accounts. That avoids storing static credentials. Policies should be modular and reusable. I prefer customer-managed policies over inline policies so that they can be versioned and reused across roles. In production, I also try to separate read and write permissions and scope resources explicitly rather than using wildcards. The guiding principle is least privilege and short-lived credentials. Second question. You deployed a new deny policy at the organization level, and suddenly multiple teams report access issues. What is your approach? Pause here. A strong answer might sound like this. First, I would confirm that the deny policy is indeed the root cause by checking CloudTrail and the error messages. Explicit deny in AWS always overrides allow, so if an SCP at the organization level denies an action, no lower-level policy can override it. I would assess the scope. Is it affecting all accounts or just a subset under a specific organizational unit? If the blast radius is large, I would consider temporarily rolling back the SCP to restore service while we investigate. Then I would analyze which specific actions are being denied and whether the SCP was too broad. Often the issue is an overly aggressive condition or a wildcard that captured more services than intended. Long-term, I would implement SCP changes in a staged manner, perhaps testing in a sandbox OU first. Organization-level denies are powerful but dangerous if not carefully validated. Third question. A CI pipeline suddenly fails with access denied when trying to push a Docker image to ECR. It worked yesterday. Walk me through your debugging process. Pause here. A strong candidate might respond like this. First, I would confirm which identity the pipeline is using. Is it an IAM user, a role, or an assumed role through OIDC? I would check the pipeline logs to identify the ARN making the call. Next, I would inspect the exact API call that is failing. For ECR, pushing images requires permissions like ECR getAuthorization token, ECR batch check layer availability, ECR put image, and possibly repository-specific permissions. I would check CloudTrail for the denied event to see which action was blocked and by which policy. Sometimes the root cause is not the identity policy, but a resource-based policy on the ECR repository or even an SCP. If a permission was recently modified, I would review the policy diff in version control. In production environments, IAM changes should be tracked as code, so I would compare the last known working version with the current one. Once identified, I would apply the minimal permission needed rather than granting broad access. Then I would rerun the pipeline in a controlled way to confirm resolution. This is not just about fixing the error. It is about understanding where the permission boundary was violated and ensuring the fix aligns with least privilege. Pause here and reflect on your own answers before moving on to the next part of the interview. Next question. You accidentally removed your own administrator permissions and cannot access the console. What do you do? Pause here. A strong candidate might answer like this. First, I would not panic. The key question is whether this is a single account or part of an organization with centralized management. If it is a standalone account and I removed my own permissions but there is another admin user or role, I would contact that person immediately and request temporary elevation to restore access. If I am completely locked out and there are no other admins, I would attempt to access using the root account, assuming it is properly secured with MFA. The root user should not be used for daily operations, but it exists specifically for account-level recovery scenarios like this. If root access is available, I would restore admin permissions by attaching an appropriate managed policy or recreating a role. Then, I would immediately review why this happened. Was it a manual console edit? Was it a Terraform apply that modified the role unexpectedly? If the account is part of an organization, I would check whether the issue was caused by an SCP deny. In that case, even root cannot bypass it. I would coordinate with the organization management account team to adjust or roll back the SCP. After restoring access, I would implement guardrails. For example, protecting critical admin roles with Terraform lifecycle rules, enabling versioned policies, and requiring peer review for IAM changes. Lockouts are usually a process failure, not just a technical one. Next question. Explain how IAM policy evaluation actually works when multiple policies are involved. Pause here. A strong candidate might say something like this. IAM evaluation is layered and sometimes misunderstood. First, AWS collects all applicable policies. That includes identity-based policies attached to the user or role, resource-based policies on the target resource, session policies if a role was assumed with restrictions, permission boundaries, and any applicable SCPs. The evaluation logic is roughly this. By default, everything is denied. Then, AWS looks for explicit deny statements. If any policy explicitly denies the action, the request fails immediately. Explicit deny always wins. If there is no explicit deny, AWS checks whether there is at least one allow that matches the action, resource, and conditions. If yes and no higher-level boundary blocks it, the request is allowed. Permission boundaries act like a maximum permission filter. Even if the identity policy allows something, if the permission boundary does not allow it, the action is denied. Similarly, SCPs act as a filter at the account level. In real production scenarios, when debugging, I think in terms of layers. Identity policy, resource policy, boundary, SCP. I use tools like the IAM policy simulator and CloudTrail to see which layer is blocking the action. The complexity is not theoretical. In large organizations with boundaries and SCPs, most permission bugs come from misunderstanding which layer is responsible. Next question. Your security team wants to enforce least privilege strictly, but developers are constantly requesting broad permissions because they move fast. How do you design a scalable permission model? Pause here. A strong candidate might answer like this. This is where design matters more than individual policies. I would start by identifying common access patterns. For example, read-only access to logs, deployment permissions to specific environments, and administrative tasks for infrastructure engineers. I would create role-based access tiers. For example, developer read-only, developer deploy, platform admin, security audit. Each role would have well-defined scopes. Instead of granting individual permissions repeatedly, we grant roles aligned to job functions. For temporary elevated access, I would implement just-in-time access with expiration, possibly integrated with ticketing. That way, developers can unblock themselves without permanent privilege creep. I would also enforce infrastructure as code for IAM, no manual console edits. All changes go through review. This allows us to see permission drift and audit changes over time. There is always tension between speed and security. The trick is to make the secure path the easiest path. If requesting access is painful, people will look for workarounds. If assuming a pre-built role is easy, they will use it. Next question. You suspect that permissions have drifted over time and some roles have far more access than intended. How do you audit and clean this up safely? Pause here. A strong candidate might respond like this. I would start with visibility. Use tools like IAM Access Analyzer and CloudTrail to see which permissions are actually used. AWS provides service last access data for roles and policies, which helps identify unused permissions. I would export policy documents and analyze them for wildcards and overly broad resource scopes. But I would not immediately remove permissions without evidence. Instead, I would create a staged approach. For a given role, I would generate a least privilege policy based on observed usage over a reasonable time window. Then I would test it in a staging environment or apply it with monitoring in production. I would also communicate with stakeholders. Sometimes unused permissions are for rare but critical workflows, like quarterly reporting or disaster recovery. Removing them blindly could cause outages. After tightening policies, I would enforce guardrails to prevent future drift. That could include policy linting in CI, automated checks for wildcard actions, and regular review cycles. Cleaning IAM is like refactoring code. It must be incremental, observable, and reversible. Final question for this section. Explain the difference between resource-based policies and identity-based policies. When would you prefer one over the other? Pause here. A strong candidate might answer like this. Identity-based policies are attached to users, groups, or roles and define what that identity can do. Resource-based policies are attached directly to a resource, like an S3 bucket or an SQS queue, and define who can access that resource. I prefer identity-based policies for internal access control within the same account because they centralize permission management around roles. I use resource-based policies when I need cross-account access or when the resource needs to trust external principals. For example, allowing another AWS account to write to an S3 bucket, or allowing a Lambda function from another account to invoke an API gateway. In complex environments, both are often used together. For example, an IAM role allows an action, and the S3 bucket policy also allows that principal. Both must align for the request to succeed. From a security perspective, resource policies are powerful because they can grant access externally. They should be carefully reviewed. In cross-account designs, I think in terms of trust relationships. The trusting account defines who can assume a role. The trusted account defines what that role can do. Understanding that separation is critical in avoiding accidental exposure or unintended access. Pause here. Reflect on how you reasoned through these scenarios. In real interviews, clarity of thought and structured debugging often matter more than memorizing every IAM action name. Let's move into some higher pressure scenarios. First question. It is 2 a.m. An engineer deployed a Terraform change that modified IAM policies across multiple accounts. Now, several production services are failing with access-denied errors. You do not yet know exactly which permission was removed. What do you do first? Pause here. A strong candidate might respond like this. First, I would shift into incident mode. The priority is service restoration, not perfect analysis. I would identify which services are failing and determine user impact. Is this affecting customer traffic, internal jobs, or a non-critical environment? Next, I would check whether we have version control for the IAM policies. If Terraform was used, there should be a previous known good state. If the blast radius is broad and we are unsure what changed, the fastest and safest path is often to roll back to the last known working version. While rollback is in progress, I would assign someone to start diffing the Terraform change. Which roles were modified? Were permission boundaries introduced? Was an SCP altered? I would also check CloudTrail for the specific denied actions to see exactly which API calls are failing. I would avoid making ad hoc console edits under pressure unless absolutely necessary. That tends to create further drift and complicates root cause analysis later. After restoration, we would perform a post-incident review. Why was such a broad IAM change allowed without staged rollout or validation? Could we have applied the policy to a single account first? Could we have used a canary approach for IAM changes? Under uncertainty, my mindset is contain the blast radius, restore functionality, then analyze deeply. Next question. Your security team wants to attach a restrictive SCP at the organization level that blocks certain high-risk actions. Engineering warns that this might break automation pipelines. You do not have complete visibility into every pipeline. How do you decide? Pause here. A strong candidate might answer like this. This is a classic tension between governance and operational continuity. I would not immediately approve or reject the SCP. Instead, I would ask for clarity. What exact actions are being denied? What risk are we mitigating? Then I would simulate the impact. AWS provides policy simulation tools, and we can test the SCP against representative roles used by CI and CD pipelines. If possible, I would apply the SCP to a test organizational unit first, rather than the entire organization. If we lack full visibility into pipelines, that itself is a risk signal. Before broad enforcement, I would work with engineering to inventory critical automation roles and ensure we understand their required permissions. If the SCP blocks dangerous actions like disabling logging or deleting CloudTrail, I would likely favor applying it, but in a phased rollout with monitoring. The mature approach is not security versus engineering, it is collaborative risk reduction. We aim to reduce the chance of catastrophic misconfiguration without silently breaking systems. Next question. You discover that a production S3 bucket has a resource policy that allows cross-account access to an external partner. The access was added months ago and is undocumented. It appears to be working fine. Do you remove it immediately? Pause here. A strong candidate might respond like this. I would not remove it immediately without context. First, I would verify what the access is actually being used for. CloudTrail and S3 access logs can show whether that principal is actively accessing the bucket and which objects are involved. Next, I would contact stakeholders. Sometimes these integrations support revenue-generating workflows. Removing access abruptly could impact business operations. At the same time, undocumented cross-account access is a security concern. I would treat this as a potential risk and initiate a structured review. Confirm the necessity, ensure least privilege, restrict resource scope if possible, and validate that the external account is still trusted. If the integration is still required, I would formalize it. Document it, move the policy to infrastructure as code, and ensure monitoring is in place. If it is no longer needed, I would schedule removal during a controlled window and monitor closely. The key is balancing security hygiene with operational awareness. Reacting impulsively to remove something that appears risky can cause more harm if not handled carefully. Final pressure question. You are asked to design IAM guardrails that prevent accidental lockouts, but leadership also wants engineers to move quickly without constant approvals. You cannot solve this with unlimited budget or new tools. What do you prioritize? Pause here. A strong candidate might answer like this. I would prioritize safe defaults and automation over manual approval workflows. First, I would ensure that critical administrative roles are protected in code. That means no direct editing in the console, no deletion without explicit review, and version control for all policies. Second, I would implement separation of duties. The same role that modifies IAM policies should not be the only path to recover from mistakes. There should be break glass roles secured with strong MFA and limited access. Third, I would enforce peer review for IAM changes in CI. Even a lightweight approval process in pull requests dramatically reduces accidental policy mistakes. I would avoid creating a heavy, centralized approval board for every permission change. That slows teams down and encourages workarounds. Under constraints, I focus on guardrails that prevent catastrophic failure, such as full account lockout or disabling audit logs, while allowing normal day-to-day development to proceed with minimal friction. Maturity in IAM design is not about eliminating risk, it is about reducing high-impact failure modes while preserving velocity. Take a moment to reflect. Which of these scenarios made you uncomfortable? Was it the organization-wide SCP, the 2 a.m. lockout, the undocumented cross-account access? In real interviews, your interviewer is listening for more than technical correctness. They are listening for how you think under pressure. Do you panic and start changing things blindly? Or do you slow down, assess blast radius, and make reversible decisions? IAM is one of those domains where small mistakes can have outsized impact. Lockouts, privilege escalation, silent overexposure of data. But it is also an area where structured thinking and careful rollout strategies make an enormous difference. If you are preparing for DevOps, SRE, or cloud engineering interviews, practice explaining your reasoning out loud. Do not just memorize definitions of identity-based policies and resource-based policies. Practice walking through trade-offs, recovery strategies, and how you would communicate during an incident. Now, I am curious. Which question in this interview was the hardest for you? The policy evaluation logic? The lockout scenario? The organization-wide guardrails? Pause the video and reflect on your answers. If you found this format helpful, subscribe for the next interview simulation. Each session focuses on a different real-world domain and pushes you to think a little deeper under realistic pressure. I will see you in the next one.